everyone. Today I am going to discuss this particular numerical on logistic regression. Okay, I will discuss some likelihood or probability regarding this logistic regression problem. This is a standard problem given in the week 3 of the NPTEL course Introduction to Machine Learning. Okay, so here what is the problem says the given table. Okay, this given table gives the binary ground truth labels yi. Okay, so binary ground truth 1 or 0. It's a two class problem. Okay, it is a two class problem for 4 input points, that is xi. So there are 4 input points xi, 1, x1, we can consider x2, x3 and x4. Okay, but these input values are directly not given. Okay, what is given? These input values are not given. What is given is some probability values. Okay, so we have a logistic regression model with some parameter values that computes the probability p1 xi. Okay, that the label is 1. Okay, compute the likelihood of observing the data given these model parameters. Okay, so we are having this logistic regression model with the parameter values that gives that computes this probability p1 xi that the label is 1. Okay, so basically this probability value which is given, this is the probability value that the label is 1. Okay, probability value for the predicting that label is 1. This probability value xi is given. Okay, directly that those input values are not given. Now I need to compute the likelihood of observing the data given these model parameters. So what is the likelihood of observing the data? So as we have seen, this is a two class problem of logistic regression. Okay, here what is actually given, that is probability that the label is 1, Okay, what is that probability for the first data point? That probability is 0.3. Okay, so from this probability, because it's a two class problem, what is also computable or observable, that what will be the probability that the class level is 0. Okay, that is 1 minus, that is 1 minus 0.8, which is equal to 0.2. Okay, but this is not required right now for this problem. And for the second data point, when that data label is 1, what is the probability value? That is 0.5. Okay, this probability value is for class level 1. Okay, for the third data point, that the label will be 1. What is the probability value? That probability value is 0.2. For the fourth data point, that the class level will be 1, that probability value is 0.9. Okay, now we also have to see what are the actual class level, what are the actual yi values. Okay, for the first one that is 1 only, but for the second one actual level is 0. For the third one the actual level is 0 again. For the fourth one actual level is. Now we have to compute the likelihood, okay, of observing the data. We have a formula for finding out, for computing the likelihood, okay. So let me change the color here. What is the formula? The likelihood for logistic regression is treated as L. In most of the books it is given as L. It is a multiplication term pi, okay, from I equal to 1 to I equal to n, considering that n number of data points are there, okay, n number of probability values we are having. This probability xi raised to the actual level yi multiplied by 1 minus probability of xi, okay, raised to 1 minus the actual level, okay. So this is the formula, okay. Now this formula will give me what? This formula will give me contribution to likelihood. Contribution to likelihood for my particular problem, okay. Now for the first data point, what will be the likelihood I need to compute, because there is less number of space, okay. For the first data point I am computing now that likelihood, okay. The first data point actual class level is what? Actual class level is 1, okay. So I will simply substitute those values in this likelihood formula. For the first yi, so this value will be what? The L value will be, this is a multiplication term, so I have to multiply to have the final likelihood value, I have to multiply all these values, okay. Now so for the first one, because this probability value that I am getting, this is for y class level 1 only, right, so it will be directly 0.8, okay. But for the second data point, what will be that contribution for likelihood? Here you can see that the actual class level is what? The actual class level is 0. The actual class level is 0 here, okay. So I will substitute those value only here. If I substitute in place of this y, it is 0, okay, then what value I am left out with? This p x I, okay, raised to yi, okay. This is, for this moment it is 0. 1 minus probability xi, okay, raised to 1 minus yi, okay. This is again, this yi will also 0. So this is nothing but, since this power term is 0, this entire term will become 1, okay, and the rest of the terms 1 minus this probability term is what? Probability term is 0.5, okay. So I will be writing here 0.5 raised to 1 minus 0, okay, which is nothing but ultimately 0.5, correct. Similarly for the third data point, if I compute this value, I will substitute everything, okay. Probability that xi raise yi, actual level is what? 0, actual level is 0, that's why multiplied by 1 minus probability, the probability value, probability xi raised to 1 minus yi, which is now 0. Okay, so this value will be, again this entire term will be 1 multiplied by 1 minus, what is this pxi value, that is 0 0.2. See, this value is 0 0.2, here it is 0 0.2. Okay, so that's why 1 minus, again 0, which is your 1 only, so it will be 0 0.8, 0 0.8, correct. Similarly for the fourth one, this contribution, the actual class level is 1, so here this will be as it is, this value will be 0 0.9. Now if I apply this final likelihood formula, okay, this final formula on this entire term, so final likelihood value will be, that is a multiplication term, as you can see, right. So I will multiply all this value, it is a multiplication term, this multiplication, right. So I will do multiplication of all the respective probability terms. So what are those values? 0 0.8, so 0 0.8 multiplied by the next value is 0 0.5, 0 0.5 multiplied by the next value is again 0 0.8, 0 0.8, so 0 0.8 multiplied by next value is 0 0.9, 0 0.9. So this multiplication final value is 0 0.288. Okay, so that's why the correct option here is third option, 0 0.28. Okay, I hope you understood. Thank you.